Welcome to this explainer, where we're going to dig right into the literal foundation of our entire food supply, the soil. It is so easy to look at an empty field and just see, well, dirt. But beneath the surface, there is a highly dynamic, living ecosystem that is constantly in a state of chemical and physical flux. We're going to see exactly how modern agriculture manages these incredible complexities. We are taking a real micro to macro journey today. We'll start with just a handful of dirt and zoom all the way out to global farming strategies. Our roadmap looks like this. We'll hit the recipe for perfect soil, then move to the good, bad, and salty, followed by the escalation of erosion, some wild plant quirks and warfare, and wrap it all up with smart farming solutions. Let's get right into it. Section 1. The recipe for perfect soil. Okay, so the recipe for perfect soil isn't just solid rock. A healthy, productive soil deeply affects every single part of the ecosystem, and it demands a really delicate balance. You need about 45% mineral mix, so your sand, silt, and clay. Add in 5% organic matter, mostly from the remains of dead plants and animals. But here is the truly mind-blowing part. A full 50% of perfect soil is actually just open space. Yep, half of it is emptiness, and that open space has to be split evenly, 25% filled with water and 25% filled with air. If you lose that open space, the whole system literally collapses. Now, nature bakes this recipe over immense periods of time using 4 key factors working in this beautiful, constant feedback loop. First, there's the parent material, the base rocks and minerals that were either already there or brought in by wind, water, or even ancient glaciers. Second is climate, which determines how precipitation and temperature weather that rock down. Third, you've got living organisms getting to work. We're talking nitrogen-fixing bacteria, fungi, worms, and snails recycling vital nutrients. And finally, topography, the natural slope, drainage, and wind exposure of the land. Give it enough time, and these factors settle into a mature state of equilibrium. The actual mix of sand, silt, and clay gives us what we call soil texture. And getting this right is a huge balancing act. Loam is the absolute gold standard for agriculture. It's the perfect, nutrient-rich, water-holding balance because it is an equal mixture of clay, sand, silt, and humus. It holds water beautifully, but it doesn't drown the plants. Compare that to clay, right? Clay compacts so easily that the upper layers become dangerously waterlogged. On the flip side, sand lets water flow through way too fast for most crops to take a drink. And silt, it's so fine that water easily just washes it right away. Moving on to Section 2, the good, bad, and salty. Depending on the environment, soils can very easily fall out of that perfect equilibrium and become totally toxic to plants. For instance, saline soils effectively drown plant roots in high amounts of water-soluble salts. Sodic soils get overwhelmed by sodium, which cranks the pH level way above 8.5. Acidic soils swing hard in the exact opposite direction, dropping below a pH of 6.0, which is awful because it causes severe deficiencies of critical nutrients like phosphorus and calcium. And alkaline soils, with a pH over 7, they are a constant, persistent plague in arid desert regions that get less than 25 inches of rain a year. There are also these intense, often totally invisible chemical battles happening right beneath our feet that drastically alter the soil over time. And these aren't just fancy vocabulary words. These processes dictate whether a region can even grow food at all. Take podsilization, an acidic leaching process that literally strips the soil of its calcium carbonates, or laterization, which removes silica and leaves behind concentrated layers that, when they dry out, turn as hard as a literal physical brick. Then there's gleization. This happens when extremely poor drainage completely chokes out the oxygen, making it basically impossible for standard crops to breathe. Now, salinization is one of the absolute biggest threats to modern agriculture. This is when salts, things like calcium, magnesium, and sodium, accumulate right there in the topsoil. It happens a lot in dry regions where unabsorbed water just sits on the surface. When that water evaporates, it leaves behind this highly concentrated, toxic crust of salt. Whether it happens from poor drainage, overwatering, or seawater flooding in, the end result is the same: stunted crops, plummeting yields, and eventually the complete destruction of plant life in that soil. And when things go completely off the rails, usually thanks to destructive human activities like overgrazing, deforestation, bad irrigation, or broader climate change, we get desertification. It's exactly what it sounds like. The productive potential of an arid or semi-arid piece of land suddenly drops by at least 10%. Native vegetation just dies off, wind erosion skyrockets, the water table plummets, and surface water disappears. Once this starts, we have to desperately scramble to plant trees and grasses just to hold whatever soil is left together. Which brings us to Section 3, the escalation of erosion. The really crucial thing to understand here is that erosion escalates. It's not usually just one sudden massive landslide. It starts with Stage 1, splash erosion. Just a single, seemingly harmless raindrop hitting bare soil. But that rapidly evolves into Stage 2, sheet erosion, where a thin layer of soil uniformly washes away across a wide expanse of land. You almost can't even see it happening. Then water starts to concentrate, bringing us to Stage 3, rill erosion, leaving visible scouring marks. Finally, if the runoff keeps accelerating, it turns into full-blown gully erosion, carving massive, landscape-scarring trenches into the earth. Now for my favorite part, Section 4, plant quirks and chemical warfare. Plants are not just passive objects sitting in the dirt. They have incredibly strong preferences for how they interact with their environment. This creates a huge contrast between sun-demanding heliophytes, think sugarcane, rice, cotton, and shade-loving cyophytes. Heliophytes are absolute sun worshippers. They need intense light to develop properly, sometimes even physically tracking the sun across the sky. Cyophytes, on the other hand, require much lower light intensities to actually thrive and survive. But here's where it gets crazy. Plants actually engage in underground chemical warfare. It's a fascinating phenomenon called allelopathy. Basically, this is the harmful effect one plant has on another competing crop species. How do they do it? They literally secrete toxic substances right out of their roots, or they leave behind toxic decomposing residues in the soil. It's a targeted strike designed entirely to sabotage competing plants, so they can hoard the soil's limited resources for themselves. Nature is ruthless. And speaking of resources, if the soil is lacking specific nutrients, crops can suffer from what's called hidden hunger. And honestly, this is terrifying for farmers. The plants don't show any outward signs of being sick. The leaves are vibrant green, the stems are sturdy. Everything looks totally fine to the naked eye. But underneath, the plant is starving from a shortage of vital nutrients, which means massive, completely unseen yield losses that you don't discover until harvest time. So, how do we fight back? Let's dive into Section 5, Smart Farming Solutions. Agriculture has obviously evolved way beyond its ancient roots. We started with simple subsistence farming, that basic grow it and eat it model, where you're just feeding your immediate family, nothing more. Then came subsidiary farming, settling on riverbanks, mixing early agriculture with hunting and gathering. But today, we need vastly more sophisticated systems. We're trying to protect the land while feeding billions of people simultaneously. To stop that terrifying four-stage erosion we talked about earlier, farmers literally reshape the earth. They build massive physical defenses through terracing, which creates embankments across slopes to slow down runoff and stop sheet and rill erosion in its tracks. They use contour farming, carefully plowing across a hill's natural elevation lines instead of straight up and down. And for crops like rice, they use puddling. This means deliberately plowing the soil while it's flooded to pack it down into a hard, impervious layer that traps water exactly where the shallow roots need it. To fight off the threat of salinization and save our fresh water, farmers are deploying micro-irrigation. Gone are the days of just flooding a whole field. This system uses a highly efficient, extensive network of low-pressure pipes and precisely placed emitters. It delivers very low volumes of water very frequently, placing the moisture exactly where the plant needs it. No massive puddles left behind to evaporate into crusty, toxic salt flats. And remember that sneaky hidden hunger? Farmers cure it using integrated nutrient management. Look, every time you harvest a crop, you are pulling vital minerals right out of that 45% mineral mix we started with. This management system is a highly calculated scientific approach to combining organic matter, inorganic supplements, and biofertilizers. It's designed to replace the exact specific nutrients that were removed, desperately maintaining the soil's fragile equilibrium. If we zoom out to the macro level, we get into watershed management. Think of a watershed like a giant natural funnel. It's an entire area of land bounded by a divide where all the surface runoff naturally collects and flows out through one single outlet, like a large river. By managing this whole massive geographical area as a single cohesive unit, communities can safely direct runoff, prevent those massive gully erosion events, and protect entire regional ecosystems at once. And this all culminates in the ultimate goal, the integrated farming system. This is where agriculture turns into a genuine masterclass in efficiency. It's all about combining crop systems, animal husbandry, fisheries, and even forestry to optimally use every single resource on the farm.
Depending on the local land, the water, the capital, and the farmer's own technical skill, these components are perfectly balanced to bring prosperity without destroying the underlying ecosystem.
As we engineer these incredibly complex systems and literally reshape the face of the earth just to save our soil, it leaves us with a pretty provocative question. Are we finally learning to perfect nature's delicate recipe of minerals, air, water, and organic matter? Or are we merely delaying the inevitable depletion of our absolute most vital natural resource? It is definitely something to think about the next time you drive past a seemingly empty field. Thank you so much for joining me on this explainer, and as always, keep questioning the world around you.